This is the first set of videos that deals with graphing polar equations. So let's get started with the first one, finding zeros for a polar equation. Just like finding zeros for polynomial functions, where you have to set the function equal to 0 and solve for the value of the independent variable, this is the same thing that we are doing here. So to find the zeros of a polar equation, remember the polar equation is r equals a function of theta. What we do is we set r equal to 0 and then we solve for theta. So for example, find the zero of the equation r equals 2 cosine theta minus 1. So what we do here is to set this equal to 0. So we have 2 cosine theta minus 1 equals 0. Now we want to solve for theta. So we add 1 to both sides, giving us 2 cosine theta is equal to 1. And then dividing both sides by 2, we'll get cosine theta is equal to 1 half. So we want to find the angle in the first quadrant whose cosine is equal to 1 half. And that is equal to pi over 3. So our theta is pi over 3 and our r is 0. So it says write your answer as an ordered pair. So the 0 of the function would be 0 pi over 3. Now this second one is finding the maximum values for a polar equation. Now recall that for both sine and cosine, the maximum value is equal to 1. For the cosine function, the maximum value occurs when theta is equal to 0. And the maximum value for sine occurs when theta is equal to pi over 2. Okay? So let's have an example. It says find the ordered pair representing the maximum value of the graph of the equation. Remember that, so this is cosine. Remember that the maximum value for cosine theta is equal to 1. So we're plugging in 1 into cosine theta. So now you have r is equal to 4 plus 3 times 1. Therefore, r is equal to 7. So in ordered pair form, we have the maximum value of this function would be r is 7 and theta equals 0. Now, supposing we have, let's have another example. R is equal to, say, 5 minus 3 sine theta. So it's the same thing. The maximum value for sine theta is equal to 1 as well. So we're plugging in 1 for sine theta. So we get r is equal to 5 minus 3 times 1, which gives us the value of 2. So for this function, the maximum value would be, the ordered pair representing the maximum value would be r equals 2 and theta is equal to pi over 2. Now, this next next slide is all about graphing a line. Now, the equation for a line in polar form is just r equals theta. Okay, so let's look at two examples. First one, we have r equals pi over 4. So your theta is pi over 4. It is, let me use that. It is right here in between pi over 6 and pi over 3. So this is our pi over 4. So let's see. If r is equal to, say, 1, let's look at this one. 1, 2, 3. So if r is equal to, if theta is equal to pi over 4, you have an r value here. Okay? This is a point where theta is pi over 4. This is a point where theta is pi over 4, but r is negative. Okay, so every point on this line represents theta equal to pi over 4. So it doesn't matter what the radius is, okay? Theta remains at pi over 4. So we have this straight line for the function theta equals pi over 4. Okay, let's look at r equals negative pi over 3. Now, since it is negative, it would be in the fourth quadrant, right? We go in the clockwise direction. So this is your negative, let me use black. This is our negative pi over 3, okay? So every point on this line represents a theta value equal to pi over 3. No matter what the value of r is, your theta remains at pi over 3. So it will be this straight line. Next, we have the graph of a circle. Okay, so there are there are several cases for the graph of a circle. The first one is if you have the equation r equals k, where k is any real number. Now, this means that any value of theta yields the same value for r. Okay, so that means if r is equal to, um, if say theta is equal to 0, your r is equal to k. If theta is equal to, say, pi over 3, your r is equal to k, and so on. So this doesn't change. The r value doesn't change. So when you graph this, for example, here, you have r equals 3, which means that for whatever value of theta is, say theta is equal to 0, your r is equal to 3. Theta is equal to pi over 4, your r is equal to 3. Theta is equal to pi over 2, your r is equal to 3, and so on and so forth. So this circle here represents the graph of r equals 3. So that's the easiest case. Now, second one, we have these different cases. All right. So the equation is either for a circle is either r equals a cosine theta or r equals a sine theta. Now, this a here represents the diameter of the circle. Okay. Um, there are different cases. Now, take note that the cosine, okay, we always associate cosine with the x, and we always associate the sine with the y. Okay, so x-axis would be the horizontal, y-axis, okay, x-axis is the horizontal, y-axis is the vertical. Okay, so whenever you have the equation a equals cosine theta, and that a is positive, it means that your circle would be on the right side. If a, on the other hand, is negative, but you still have cosine, so that still refers to the x, your graph would be on the left side. Now, if you have sine and a is positive, then your circle would be opening up. And if a is negative and you have sine, your circle would be down. Okay? So we'll just try to have 4 points when we graph a circle, so that we have 4 representative points on the circle. So let's take a look at example number 2. So example number 2, we have r equals 4 cosine theta. So you'd know that your circle would be on the right side, because First, A is positive, and you have cosine, so it should be on the x-axis. Okay, so let's take a look at this example. Okay, so this is the right side. This opens on the right side. And then your A is equal to 4, okay, which is also your maximum value, right? That's the diameter. That's also your maximum value. Um, okay, so what do we have here? We start at 0, 0. Okay, maximum value is 4. So we count 4 on the x-axis. 1, 2, 3, 4. Now we said we need another up 2 points. So since in this particular case, you're given the graph for pi over 4 or 45 degrees. So you can either use pi over 4 or 45 degrees, put it into the calculator. So we get r is equal to 4 cosine 45 degrees if you have your calculator set to degrees. And that gives us 4 cosine 45. That would be equal to approximately 2.8. Okay. So 2.8 when pi over 4. So 1 to 2.8 would be somewhere here. Okay. And this is symmetrical onto the other side. So we have another point right here. And we just connect these 4 points by a circle. It doesn't have to be perfect. So this is your circle for 4, r equals 4 cosine theta. Now let's take a look at number 3. So here, your A is negative and you have sine. So that means this would open, or your circle is below the 0 pi axis. Okay? And the distance from that center to the other point would be 6 units. So we count 6 units down. 1, 2, 3, 4, 5, 6. Okay, our space is just enough. And then again, let's find another 2 points. So again, let's just use pi over 4. So negative 6 sine 45 degrees. So we get negative 6. Let's just have the answer. And anyway, let's do this. Sine 45 is square root of 2 over 2. So what would our R be? We get negative 6. That gives us negative 4.24. So R is negative 4.24. So sine 45, this is your 45 degrees. R is negative, so it would be on the other side. So 1, 2, 3, 4.24. Let's say it's somewhere here. And it's symmetric onto the other side. So we have another point right here. And your graph would look something like this.